Hi, my name is Dan Parker. I'm the facility manager here at St. John's Cathedral, and I've been asked to share with you a little bit about this new HVAC system that we had installed in this cathedral, and talk to you a little bit about why it's more efficient, why it's going to help us reduce our carbon footprint here, and how it's going to ultimately reduce the cost of our energy consumption here at St. John's. I think it's important for us to talk a little bit about what used to be here and why it was that we upgraded. And the old system that we had was an old 1 million BTU burning boiler system that used steam heat. And the problem with that is it's so incredibly inefficient in that when that boiler fires up, it has to fire up to complete capacity to send even just a little bit of heat to a radiator that may be at the very back or the front of the cathedral. And in doing so, those pipes heat up the building all the way over to here, and all of that energy is lost in the building. You may have a place where the building is 80 degrees in one room, and over here it's 60 degrees, and the building was just, the system was just inefficient. So we went to this new system, the VRF system. If any of you have ever walked around your house and you have an air conditioning unit, outside is this big fan, and it's blowing out a lot of heat at the same time that it's cooling your house. Well, a VRF system is going to capture that heat and actually use it. And the way that it does that is it just reverses the flow of that temperature, or that coolant. That coolant is then, in that system, is reversed, and it brings the heat inside and it lets the cool outside. And that's basically the way that works. Instead of letting that heat go, we're actually going to capture it in the building and use it in different locations of the building instead of letting it go outside, or vice versa with the cooling. So the best way for me to explain this to you is, let's take a typical Sunday here at the cathedral. We open up the doors for church, and when we do that, the front end of the cathedral, if it's 50 degrees outside, that 50-degree air starts to blow in the front of the cathedral. And then the choir and everyone starts to warm up, right? So what this new system does is it's actually a smart technology. So it's censoring that air that's up there in the chancel, and it starts to realize, okay, I'm going to call for some cold air. But back in the back, it needs a little bit of hot air because the doors are open, it's 50 degrees, it's coming through there. So the hot air kicks on over there, and the cool air kicks on up here in the front of the cathedral. The whole idea behind this system is to maintain a set point of temperature. So we try to keep this cathedral at 68 degrees all the time. So the way that this system works, and the way it works more efficiently, is that we just push out just enough air to keep it at that set point. And by doing that, it doesn't require that the system come up to full blast to actually make that area cool. It can do it with a fan speed that's very low, and a very low amount of refrigerant is required to actually cool this area and heat the area in the front of the church. The other great thing about this system is that if you ever notice and you've sat in a hall with a lot of people, you start to notice that it gets a little bit stuffy while you're in there. Well, this system recognizes that. There are CO2 sensors throughout the cathedral, and those CO2 sensors then send information to what is called a DOAS unit. Basically, it's a vent, right? Those vents then open up and allow fresh air into the area until that CO2 level comes down. And it makes for a much more comfortable system. And hopefully, our hope is that you never really notice that there's much of a temperature change here in the cathedral. The great thing about a system like this is that it takes us almost completely off of using any type of fuel source. So we have no natural gas to this system. It's electricity run, and that and its efficiency will really help us reduce this carbon footprint that we have. It'll also really reduce the cost. This system, it only runs when it's needed, and it so tracks every space at every moment in the cathedral that it only uses the smallest amount of energy possible just to heat or cool that particular area. Ultimately, it has made us more comfortable, more welcoming here in the nave, and more environmentally friendly. Thank you so much.